Hi, everyone. That's right. It's happening. After an approximate time of multiple months that I don't want to check the exact time, we're doing another science stream. And it's probably... I don't think it's been a year. So we're so good on that. But hello, if you don't know how this works, or if this is your first science stream with me, Caprolux, I basically just go through a bunch of random news articles, more or less, about different science happenings that are going on, and kind of either learn a little bit about what is being said, possibly even go over the details more explicitly, just to sort of see, like, you know, depending on how it's reported, see if there's other things to it. But yeah, it's just a fun time to sit down and discuss a bunch of different scientific topics. So I have a few things today, and of course, people can always suggest some stuff as well, because I'm always down to look through different things. So let's get started. This first one that I got here is talking about human echolocation, and basically how we as humans can also use echolocation. And I thought this was pretty interesting because I was like, you know, I never really thought about our own echolocation capabilities. But this says a study reveals how individual tongue clicks and their echoes contribute to object sensing. Obviously, not one of our huge evolutionary points. We didn't really rely on hearing as much as our sight. Yeah. But let's see. So, navigating the world as a blind person sometimes involves using a cane, guide dog, or wearable GPS system. I don't know about this. Wearable GPS system. Hold on, I gotta look into this. Tracks location, movement of the body. But like, I don't know how that works for a blind person. Oh man, you know what? It's actually been so long since we've done a science stream. The AI overview actually wasn't a thing yet. That's crazy. But if you know anything about me and my stance on AI, we're not using it. We can't rely on that. Yeah, there's... Oh my god. Let's see, can I just get a picture? I'm just curious what... He's holding a whole, like, damn... Like, he's holding this little device, but he's holding a whole damn, like, DVD player or something. This page is completely broken. Do we still use GPS devices? Okay, I mean, it's so hard to tell. A lot of the... See, this is the thing with science. Is, having to navigate basically an internet that everyone can use. And I see a lot of things on here that they look conceptual and not like a real product, you know? And I'm just like, I want to know what the real product is. I see, it looks like this is a thing. But see, it's like, I don't know if this is actually a product or if this is just some venture capital type stuff. To where they're just like, look at this totally real thing, please give us money. But I guess that could kind of work. Interesting. Anyways, I feel like I'm getting way off base, but that's how it be. Ah yes, the bone stimulator. GPS module, main controller. What would be like the troubleshooting of the tech if your GPS is kind of off base? It's like, hey, you're running into a building, and the person's like, I'm clearly not. Yeah, it seems like it's a lot. It seems like most of them follow a train of like haptic feedback, and I guess using GPS. So okay, that's interesting. I didn't know about that or think about that ever. Let's see. For some, this toolkit includes echolocation. Producing tongue clicks and listening for echoes can be enough to gain information about nearby objects. Even for expert echolocators, a single click is rarely enough to perceive an object. Echo after echo incrementally improves understanding. Especially for expert echolocators, researchers report April 6 in eNeuro. The finding helps explain how the brain processes sound more generally. Many studies have shown that echolocation recruits visual areas of the brain, that performance improves significantly with practice. That's what I was thinking. Definitely not a skill you just probably already have, but a little bit of training. I could see it working. I could see it working that way. What remained unexamined here was how this happens. How the information builds in real time over individual echo signals, says cognitive neuroscientist Santini Ting at the Smith Cuddlewell Eye Research Institute in San Francisco. I've talked about this a little bit. Another thing that I kind of worry about with, we'll say, big technological changes, especially with ones have to deal with disabilities. It can be kind of scary because a lot of times, again, companies will just basically use venture capital. So they'll basically just say, look at this really great idea. It's so revolutionary and it'll fix like this specific problem. And people are like, oh man, that's great. And then so some people jump on it and, maybe the company gets some investment at first, but then the company basically goes under. And then these people that, jumped on using this technology, they have no support system now. And so depending on the technology, like I should remember it because I always use it as an example, but there was this company that for blind people, it actually, I forget exactly how it got installed, but basically it helped improve some blind people's like vision, like they could actually see a little bit, and it was really cool. But then the company went under, and then it was like, well, anyone that needs help with this thing can't get help now. And I'm pretty sure it replaced their whole eye, and after a while the battery in people's devices started dying. And so it's like, well, now it's like I just have this like thing in my head now with a dead battery, and I don't have like a company or anything to help me remove this. And so that it's like, how can you, like, it's just crazy how quickly a company can go under, and then anyone that used the technology that they touted as like, oh, this is going to be revolutionary, is just gone. And it super sucks. And, I'm not saying that people shouldn't jump on something like that, because that'd be like definitely really cool, but I would definitely say be cautious, be wary of companies that do this kind of stuff. Anyways, let's see. Ting and his team attached electrode caps to record brain activity in 4 blind expert echolocators and 21 sighted novices as they listened to pre-recorded clicks and echoes. The sounds were played in sets of 2, 5, 8, or 11. After each set of clicks and echoes, the participants decided whether the object was to their right or left. Okay, so let's see, electrocaps. Okay, so it was pre-recorded clicks and echoes, so they just basically, I guess, had to tell, is this coming out of your right or left, like, headphone or whatever. In line with previous research, expert echolocators are far better at determining the direction of an object than people who can see. One exceptional echolocator needed only to hear 2 sets of clicks and echoes to determine an object's direction. Okay, so... Is it... Hold on, I'm kind of confused. So, I'm guessing the sounds... Okay, so I guess, like, per click, like, set, it would be like, oh, 2 clicks on the left. So you could be like, oh, it's on the left. Or, like, say, 11 clicks on the right. And then you're like, you know, by, like, the 5th or 6th one, you're like, I'm pretty sure that's on the right. But I think this is, like, the harder one of, like, you know, can you tell with just 2 clicks which side it's on? Let's see. Unlike in previous studies, the team used the brainwave data to show that each click-echo pair added to the evidence the brain was accumulating to make the perceptual decision. The study suggests that in human echolocation, spatial representations are constructed by progressively accumulating acoustic evidence over time, rather than through a single optimal snapshot, says neuroscientist Monica Gori at the Italian Institute of Technology in Genoa and the Institute for Human and Machine Cognition in Florida, who is not involved in the study. That's also interesting. I realize I read this a lot with these articles, that a lot of times the people that are interviewed, they're just like, oh yeah, they weren't involved in the study. And I'm like, why? I'm like, why aren't we asking the people involved in the study then? Team wants to continue to understand what exactly makes better echolocators, says cognitive neuroscientist Hey Garcia Lazaro at the Smith Cuddlewell Eye Research Institute. In addition to tracking the information echolocators gain from each click, she's interested in how experts learn to ignore the click itself and attune only to the echo. Huh. Okay, so relatively small one. But that, let's see, when humans echolocate, they send out a signal, typically a click, and listen for the return echo. I think, so when they talk about echolocation, maybe we should look into it, because it sounds like this study looked at directional stuff, but I was kind of curious more about the kind of, like it said, the spatial, you know, being able to tell, like, oh, I'm right against a wall, or like, oh, there's a wall, like I can walk, you know, approximately like 20 feet or whatever. I was a little bit more curious about that. Let's look at the abstract real quick. Enables blind individuals to receive and navigate their environment, emitting clicks, interpreting their returning echoes. Blind expert echolocators, all males. Ooh, big. One thing that definitely needs to be done in a lot more studies is diversity. Because as scientists, we always gotta check, like, here, let me zoom into this a bit. We always gotta check, like, different demographics, because even if we think something can be different in males, like, it really, or, like, think it's not different in males versus females or other demographics, it's like, there very well could be, and we have to basically prove that there's not a difference. We have to be sure. So, actually, I'm also curious about the, and I'm sure it's in here somewhere, of how they got these participants. Because I'm always curious with different studies, how they went about it. Let's see, this was done where? Let's see. Thank you for your time and consideration. Cool, where? Let's see, reference. We had one. Let's see. Some of the details in Figure 1A are difficult to see. Response thanks for highlighting to increase the font size and the resolution. They had... Is this 2 papers for references? Very interesting. Interesting. See, this is why we sometimes go to the journal itself, because it's like, oh. Because it's like... Oh, okay, here we go. I guess I was just with some slight edits, because I was gonna be like, you got no references on this paper? What? See, no competing financial interests, and also whenever they're completely honest about it, it's very interesting to see all the acknowledgments and see if there's any conflicts. Like, oh, this study was done, like, one of the head scientists in this study was done by someone who very much has, like, you know, like, stock in this company or this idea or whatever. And it's like, oh, it's like, then I wonder why you did that study. Let's see. This was done. I Research Institute, CBSR. Oh no, it's supported by. I'm just curious where it was done. Oh well, I guess it's not super important. Let's see. So, echolocaries, novice-sighted participants. Does this just mean people that are not echolocators but can also see? Virtual spatialized echoes derived from realistic synthesized mouth clicks. It's interesting that they gave them synthesized mouth clicks and didn't just allow them to provide their own mouth clicks, but you know, it's fine. Behavioral results show that blind experts signal got performed. Yep. Okay, yeah, so they were side controls, and also only 4. Probably, well, I don't know. Again, I don't know how you recruit an echolocator, but probably could have used a couple more. I'm just gonna check echo library. Wait. Correlate overall spatial light. Yeah, so let's. Across successive clicks, neural responses evolve systematically, reflecting sequence position dependent changes in neural dynamics. So kind of just more or less what we went over. Let's see if there were any figures about the distances. Because I'm assuming these synthesized clicks are all at, like, I guess the same volume with the echoes. Okay, so I guess they have... Okay, so it wasn't just left-right, that actually varied the degrees that was at. Okay. Simple 2 clicks. Response queue, on-time response, blah, blah, blah. Multivariate pattern analysis, left-right. Okay. So yeah, they were probably a little bit more in detail than the article is letting on. So it seems like they actually took the degree of where the click was coming from, which is interesting. Clicks between blocks is needed. Total experiment time is 70-75 minutes. Trying to see. Okay, so they segmented how long between the clicks, I think. But I'm not sure if I'm immediately seeing anything saying that there was a specific difference in time of the click versus the echo. But okay. Interesting. Anyways, we'll move on to the next one. So this one I thought was pretty cool. Well, cool might be... it's interesting. It's all interesting. Science is always interesting. But this one's about sharks and how they're ingesting drugs in the Bahamas. And yeah, so it's not about human pollution of drugs, but I'm curious to see what they found in the sharks' bloodstreams to be like, oh my god, these sharks are full of meth. It's crazy. Oh, it's cocaine, caffeine, painkillers. Okay. So sharks off the coast of the Bahamas are getting into drugs like cocaine, caffeine, and painkillers. Or rather, drugs are getting into them. The contaminated blood of species, including nurse sharks and Caribbean reef sharks, reveals the damage humans have done to paradisiac oceanic environments. To which I'm just like, damn, how much cocaine, caffeine, or painkillers is being dumped in the ocean, man? awful addictions for these sharks to get when they can't, they can't really get anything for it willingly. So let's see, we're talking about a very remote island, Bahamas, says Natasha Wozniak, a biologist at the Federal University of Paraná in Brazil. Wozniak is part of a team that has analyzed pollutants in sharks in the Caribbean and Brazil. In previous research, they found cocaine and rare earth elements in sharks off Rio de Janeiro. For a new study published in the May Environmental Pollution, the team analyzed blood from 85 sharks captured around Eleuthera Island in the Bahamas. And maybe we'll be able to see, but I wonder if they tag these sharks? Because it'd be interesting to see their swimming patterns, like if they stick around those shores, or if they do travel a good distance as well. Let's see, testing for nearly 24 legal and illegal drugs. 28 sharks from 3 species had caffeine, anti-inflammatory painkillers, or other drugs in their blood. Some tested positive for multiple drugs. Caffeine was the most common, followed by acetaminophen and diclofenac, the active ingredients in Tylenol and Voltaren. Damn. Most sharks were caught about... So again, I'm like, where's the dumping grounds for this stuff? Most sharks are caught about 4 miles offshore, around an inactive fish farm popular with divers. Wozniak says currents could carry drug traces from sewage or other sources on the island, but divers are the more likely culprits. Ooh. These divers are just coming in and dumping their coffee or whatever they have. It's mostly because people are going there, peeing in the water, and dumping their sewage in the water. Damn, sad. These sharks are just getting high on pee-pee water. One shark, a baby lemon shark in a nursery creek, tested positive for cocaine. Oh my god. Let's see. Wozniak flips an earth starch upside down to take a blood sample. Our colleagues look on. I wonder, is it hooked? I'm curious how to get the blood sample from the shark. The amount was far lower than what researchers previously found sharks off Brazil, but that earlier study examined muscle tissue, not blood. Huh, interesting. Was it the purpose? Because I feel like if you were purposefully checking an animal for drugs, you would want to check blood and not muscle, but yeah. So I wonder if that original study, if that was the purpose, was to check drugs, or if they were doing something else with muscle tissue. Because drugs persist longer in muscle, okay, that's why. The presence in blood points to recent exposure. That's also what I was thinking. I was like, if it's in the blood, like, that must mean it's a recent intake. Wozniak says the shark may have ingested a packet containing cocaine residue. She's seen such packages near that creek before. They bite things to investigate and end up exposed to substances, she says. Damn, how many of these divers are doing cocaine? You know, I'm not gonna lie. Maybe I'm just a maybe I'm just a square. But, like, I feel like way more people do cocaine than I realize. Because I feel like it's always just the, like... It's the drug you hear about in a lot of situations. And I'm always just like, man, who... You know, like, if it was weed or something, it's like, sure, you could get weed, like, anywhere. But it's like, who's taking all this cocaine, man? Who's got it? Who's dumping it? Team also found... Also, wouldn't it be expensive? Why are these divers dumping their cocaine? team also found changes in metabolic markers in sharks with contaminated blood, including lactate and urea. It's not clear whether shifts are harmful, but they might impact behavior. Research in goldfish suggests caffeine increases their energy and focus, Wozniak says, much as it does in humans. What makes the study notable is not just the detection of pharmaceuticals and cocaine in nearshore sharks, but the associated shifts in metabolic markers. Says Tracy Finera, an oceanographer at the University of Florida in Gainesville, who is not involved with the study. You know, I will say, even though they're just asking relatively random scientists sometimes, I'm glad they specify. There's like, they weren't involved, just so you know. Let's say while the researchers couldn't isolate the effects of individual drugs, contaminated sharks showed changes in markers tied to stress and metabolism. Wozniak says the findings are concerning because the Bahamas is seen as a relatively untouched paradise. But like plastic pollution, she says, chemical pollution is more pervasive than many people realize. In the Bahamas, she adds, such pollution is often overlooked in favor of concerns like oil spills or plastic. Yeah, if it is seen as like a relatively untouched paradise, I'm willing to bet that both people would be like, oh, like, cool, let's go there, and then fuck it up. You know, whether intentional or not. And also, officials would maybe be like, we want to keep this image that we're an untouched paradise, so we can't let people see that shit's getting polluted. Venera, who previously helped produce Cocaine Sharks, a documentary examining the possibility of sharks were encountering cocaine trafficked in the Caribbean, says the findings are a reminder that coastal infrastructure, tourism, and marine food webs are tightly connected. There's a documentary? Cocaine Sharks. This is short. Scientists test the theory that sharks come in contact with cocaine. Wow, very specific. Not to be confused with Cocaine Shark, the assumedly a sci-fi. Oh, it's on Tubi. Okay. This is maybe also something I'll want to check out. Okay, so this documentary came out in 2023. What are you on? Ping Pong Productions. Okay, it's like a 40-minute documentary. Interesting. Can we, let's see, can we look at some reviews? Let's look at actually, it looks like people hate this thing, actually, now look at it. Oh, I didn't realize this was out of 10. I thought this was out of 5. Let's see, what are people saying? Oh, sign in to access user reviews. Get fucked. Okay, but interesting. I'll keep Cocaine Sharks in mind. That'll be interesting to see. Moving on. So, 3 supermassive black holes discovered in a single galaxy for the first time. Which, I never really thought about, but I'm surprised that is the first time that 3 black holes have been seen in a single galaxy. We're getting closer and closer to outer wilds. Let's see, an international team of astronomers led by the Max Planck Institute for Extraterrestrial Physics has identified 3 actively green supermassive black holes in the galaxy. J0148, 4214. I wish I knew what went into identification of galaxies and what exactly this meant. Matter is falling into the black holes from accretion disks surrounding them. Also, I'm curious how close they are, assuming, let's see, map of the distant galaxy and ionized hydrogen. Okay, yeah, so I'm curious if like they're really close to each other. And the idea of what if 2 black holes get close to each other, can they suck each other up? Like what happens there? Galaxy is located more than 12.5 billion light years from Earth. At this distance, the expansion of space itself becomes apparent. The galaxy therefore appears to be moving away from us, causing its life to shift towards longer wavelengths, resulting in a so-called redshift of z equals 5.02. I don't know exactly the exact redshift, but this is It's really, I remember learning about how we measure distance in really distant galaxies and stuff, and basically how we learned that, oh, the universe is always expanding, but just basically how red is the longest wavelength of visible light that we can actually see. So he basically calculated, came up with a measurement to calculate how, I forget if it's how much red light is reflecting off a distance, or how long it would take or something, but basically we can tell the distances of things through redshift. Let's see, using that redshift, the researchers calculated the galaxy's enormous distance. It is so far away that its light has traveled for 12.5 billion years. We're therefore seeing the galaxy as it appeared only about 1.2 billion years after the Big Bang. This is the first evidence of 3 active black holes in a single galaxy in the distant universe, says Hannah Ubler, research group leader at MPE and lead author of the study. Research published in the journal Astronomy and Astrophysics. 2 are located in the galactic center and are separated by only 620 light years in projection. A third black hole is located in the outer region of the galaxy, interesting, at a distance of approximately 5,500 light years from the center. It suggests that processes in the early universe were efficient at bringing massive black holes together, setting the stage for the massive black hole mergers we expect to detect with future gravitational wave observatories. Okay, so I'm guessing this means that the ones in the center will merge. And interesting that black hole popped up in the outer region, so I wonder how that affects everything like swirling through the galaxy. Theories of galaxy evolution based on observations suggest that early in the history of the universe, galaxies came very close to one another and merged. In the process, black holes at their centers also merged, giving rise to even more massive black holes at the center of the merged galaxies. That's interesting. I wonder, with the theory of the black holes being merged, how how that would work with their density. Like, does it just compound, or does it, increase exponentially or something? Hydrogen emission as a tracer? It really wants me to share it. The researchers identified the black holes through their spectral fingerprints, the signatures of hydrogen atoms moving at high velocity, and the gravitational potential of the black holes. In the central region, the spectrum exhibits a complex structure best explained by 2 black holes in close proximity. To disentangle the 2 central sources, the team applied spectroastrometry, a technique that precisely measures spatial shifts and light emission across the galaxy. I will admit my science is not exactly astrophysics, so a lot of terminology here, I am just picking up like the gist, but I would have to look things up if I want to explain in detail how certain things work. So if anyone wants me to, just ask, so then I will. This made it possible to determine the positions of the black holes, even though they cannot be spatially resolved as separate point sources. Okay, so it seems like they're so far away that they're like, these 2 black holes are very close together, so we just see in like this one point the 2 black holes, but they can determine that they are 2 different black holes even if it doesn't readily look like that, basically. Third black hole is detected in the outer region. Masses and growth. The analysis yields black hole masses of approximately 80 million, 0.6 million, and 2 million solar masses. The most massive black hole is accreting at a lower rate than the nearby black hole with a mass of 0.6 million solar masses, which is actively feeding and even exceeding the maximum accretion rate predicted by basic theories of black hole growth, the Eddington limit. I wonder, with this one being such a huge difference, I wonder if there's already been black hole merges that have happened. The JWST data allowed us not only to identify the 3 black holes, but also to estimate their masses, accretion rates, and the stellar mass of the galaxy, says Dr. Giovanni Azzolari, second author of the study and researcher at MPE. We find a total stellar mass of about 1.3 billion solar masses, and the black holes represent a significant fraction of that. I didn't know... You know what? How much is a solar mass? Because I didn't know we had a, I guess, like, an amount that we studied by. Oh, I don't want to... I can't use the AI. Let's see. Solar mass is frequently used unit of mass in astronomy, equal to approximately... Okay, so it is just the sun. I love that we take measurements of just essentially, I'll say, random objects. So we're just like, you know what? The mass of our sun is like about this much, so we'll just measure things based on that. Because that's what we got. It just how that's always been like the idea. Yeah, indicate the masses of other stars as well as stellar clusters, nebula, galaxies, and black holes. Same thing with like light years. We're just like, you know what? At the speed of at the time it takes for a speed of light to travel 1 year, like that's the distance of 1 light year. And they're like, yep, that'll be good. That's not that confusing. Like, we'll go with that. Let's see. Okay, yeah, black holes represent a significant fraction of that, which I guess makes sense, right? Central black hole pair is expected to merge within the next few 100 million years. Ooh, stick around for that. These results are extremely exciting, adds Roberto Maiolino, professor at the University of Cambridge and co-author of the study. They suggest that black hole merging may be an additional fast route for their rapid growth in the early universe. The third black hole, located off nucleus, may be the remnant of a previous merger, be displaced from the center by a gravitational recoil kick, or be currently migrating inward. Man, black holes are such a mystery. I'm curious, because like obviously a lot of times we only see black holes because the way light and everything kind of refracts around it. But I wonder if there's like any really old ancient black holes that they are no longer in a galaxy or surrounded by other like celestial objects, and so it's just there in the universe all by itself, and there's no way for us to necessarily detect it unless we're trying to look at I think the music cut out, unless we're trying to look at some stuff like way behind it. I am also curious if what if like black holes had to continuously be taking in matter just to be able to sustain itself, but then once there's nothing around it, it just kind of like peters out or disappears or something. I don't know. I don't know much about the theoretical black holes to know the answer to that. Implications for research. These observations demonstrate that integral field spectroscopy is an important tool for identifying multiple active black holes in distant galaxies. Without the spatially resolved information provided by NIR spec AFS, only one of the 3 black holes would likely have been detected. Probably the really big one. Okay. Well, that's pretty cool. Because I'm curious now in how many other galaxies we can detect multiple black holes. Let's see. I'll go into this one, and then we'll get into something a little bit more, I'll say, silly. So scientists discover a hidden brain rhythm that could improve Parkinson's treatment, which that sounds pretty interesting. When I first read this, I was just like, I was immediately like, what if it's just the brown note? We actually have to subject Parkinson's patients to the brown note, and then it'll actually help their treatment. So let's see. Deep brain stimulation can reduce movement problems caused by Parkinson's disease, and new research is providing a clear picture of why the treatment works. Scientists have found that its benefits appear to depend on stimulating a specific brain network that communicates primarily through a relatively fast beta rhythm, 20 to 35 hertz. Okay, so we actually have a measurement for it. Findings come from an interdisciplinary group of neuroscientists and clinicians at the University Hospitals of Cologne and Dusseldorf, Harvard Medical School, and Charité Berlin. I probably mispronounced the German. Oops. Published in the journal Brain, the study of the deep brain stimulation response network in Parkinson's disease operates in the high beta band. It's the first to bring together two approaches that have largely been studied separately: electrophysiology and brain imaging, pinpointing where and how brain stimulation works. For the first time, we were able to characterize the DBS response network in Parkinson's disease in terms of space and time simultaneously, says Professor Dr. Andreas Horn from the University of Cologne, who led the study and specializes in computational neurology. We showed that Parkinson's disease can best be treated if we stimulate a very precisely defined network. This network operates synchronized within a specific frequency band and offers an explanation for how well patients respond to deep brain stimulation. So basically, I think they're just saying, like, well, I guess I'm curious, but they're saying that if we stimulate this, like, specific frequency band, then Parkinson's disease has the best, like, outcome, more or less. But I'm curious how they measure the differences of treatment. Deep brain stimulation of the subthalamic nucleus is already an established therapy for easing motor symptoms in people with Parkinson's disease. Okay. Treatment uses implanted electrodes to deliver small electrical pulses to areas located deep inside the brain. So it sounds almost like a little massage to your brain, to be like trying to tell your those parts of your brain, like, hey, come on, like, let's get to work in, so that, like, let's get your motor skills going. But that's obviously very, very heavily simplifying it. Previous research has provided only part of the picture. Brain imaging studies have helped identify the locations where stimulation appears to work most effectively, while physiological research has measured the frequencies of the electrical signals involved. Until now, researchers had not captured both the spatial location and timing of these signals at the same time. And this is why scientists in different fields gotta work together. Because we can look at things from different angles, but we gotta combine those angles so we can get a better picture. Because yeah, being able to know the location and frequencies of the electrical signals that would help would be very good. Mapping the Parkinson's brain network. Ooh. To investigate this connection, the team studied a large multi-center group consisting of 50 patients and 100 brain hemispheres. The scientists... oh my god. That's a lot. The scientists simultaneously recorded brain activity through the implanted DBS electrodes and with magnetoencephalography. MEG. Using these recordings, they mapped functional connections between regions deep within the brain and areas closer to its surface. Their analysis revealed that the important network connecting the subthalamic nucleus with frontal areas of the brain communicates largely at a comparatively fast frequency. So, I wonder if it would be how fast the frequency is, like how noticeable it would actually seem. Importantly, the strength of this connection was associated with how much individual patients' motor symptoms improved following the electrode implantation, a brain rhythm that may shape treatment response. These results suggest that a certain rhythm of the brain acts as a communication channel between the subthalamic nucleus and the cerebral cortex, and may mediate the therapeutic effects of deep brain stimulation. It's basically just saying, like, if we keep up this rhythm in the brain, then it may be able to act as like a bridge between these two portions of the brain that are, usually not as connected. Explains Dr. Benny Banners, first author to say, who works at Dusseldorf University Hospital. By simulating regions that are connected to the identified network, we will probably be able to adjust DBS settings more precisely in the future, especially in patients who have not yet benefited optimally from deep brain stimulation. The findings could therefore provide a foundation for deep brain stimulation more precisely tailored to an individual patient's brain network, particularly when existing DBS settings do not provide the desired level of symptom relief. Researchers now plan to investigate more directly how deep brain stimulation causes changes within brain networks. So he's examining these causal effects are currently underway. I'm kind of curious though, because it didn't really talk about man, damn it. I wanted to see if I could find more details on how they actually looked at the treatment results and how that seemed to help. But you know what, that's okay. And lastly, I want to talk about this because I read this first part and I was like, okay. There's a rumor Earth will lose gravity for 7 seconds on August 12th, 2026, killing millions of people. Here's why it's total junk. And looking at the current time and date, I don't think that happened. I don't remember the entire planet suddenly losing gravity. But I just wanted to talk about the ridiculous anti-intellectualism that's spreading everywhere with people. Because I'm sure we'll get the backstory, but some random TikToker, I guess, saying hey, listen, gravity's gonna turn off, bro, for 7 seconds. Because just the idea, gravity can't just turn off. That would basically mean that all of Earth's mass and density just disappears as well. So I wanna see what the ridiculous thought process is, but also how, and who knows how many people actually believed it. This could just be one random asshole and everyone could have clowned on them for all we know. But it happens seemingly so much where someone just comes up with some, schizo theory of something. Let's see, people linking eclipses to scary stuff is nothing new in human history, but it's largely nonsense. Oh, is it because of the eclipse that was happening? Because, I don't know, I love that because it is just very ancient human history of you to be this eclipse is happening and that means bad shit's gonna happen because the moon's covering the sun. Let's see, we understand that we're in the age of misinformation, the post-truth era, a time of AI slop making the most stupid claims, but come on. I also like the tone of this article. The Earth will not stop having gravity for a random time on a random day this year. How and why? Gravity is not something you switch on and off. Even elementary school children know this. Thank you, Dr. Alfredo Carpenetti. I would like to tell you that I have now got this rant out of my system, but I can't. The whole idea is the idea that Stanley Kubrick staged the moon landing looks serious in comparison, so let's get into it. NASA knows. As reported by Snopes, a TikToker and Instagram user whose account is now unavailable, damn, shamed into being so fucking wrong, claims that on August 12th, 2026, the world will lose gravity for 7 seconds. NASA knows. They're preparing, but won't tell us why. How do we know they're preparing? And, Who's asking? What do you mean they won't tell us why? How do you know they're preparing for anything? Video has almost 62,000 likes and has been shared 268,000 times on Instagram alone. Also with this, like, obviously they haven't named anyone so far, and it's like, this could have, like, kind of like they said with AI slot, it's like, it could just be an AI thing, just randomly making bullshit up as well, just to try to get, like, ad revenue. How does this person know all this? A leaked NASA document, Project Anchor, reportedly leaked in November 2024, and with an $89 billion budget. The expected falling casualties are in the 40 to 60 million, which is actually massively low considering there are people that are outdoors at a given moment all over the world. I was gonna say, like, 40 to 60 million people is kind of like not shit comparatively. Like, if gravity actually turned off, the casualties that would happen would definitely be at least in the billions. Like, it'd be insane. Let's see, eclipses in the apocalypse. August 12th, 2026 was a very nice choice when it comes to making end of the world conspiracy theory, as is the date of this year's total solar eclipse that will be seen from the Arctic to Spain. People love to link eclipses to doom, as if many different civilizations have not been able to predict them for thousands of years. Then we have the 7 seconds, and it's very funny how they have broken down what occurs in that time. People, animals, anything not locked down, start floating in the first 2 seconds. Then it will continue to rise during the 3 to 4 second interval, reaching 15 to 20 meters, 49 to 65 feet in the air. Now, the first law of dynamics shows that a body at rest will remain at rest unless an outside force acts on it, and a body in motion at a constant velocity will remain in motion in a straight line unless acted upon by an outside force. It's true, if people started going up, they would just keep going, or at worst, like, maybe keep going forward, but they're like 2 feet off the ground. You don't just, it's not like gravity reverses and you just, everything goes up. Under gravity, you have an equal and opposite reaction, pushing off the floor. With gravity magically gone, that reaction will push you off, but it will be small. Unless you jump at the right time, you're not getting 20 meters up in the air, but wait, there's more. The finale is that 7.3 seconds, inexplicably, gravity returns and everything comes crashing down. Is there any logic behind this silly rumor? So, yes, this is my biggest question. What will cause this momentary blip in gravity? According to the rumor mill, the intersection of 2 gravitational waves from black holes predicted in 2019 with a probability of 94.7%. NASA has known about this for 5 years. It is impressive how many things one can get wrong in a single sentence. Let's break it down. The fact that they couldn't do the math between 2019 and 2026? Let's say intersection of 2... See, I mean, like, they just throw words at you, man. Gravitational waves from black holes. And with a probability... Like... Is the probability of 94.7% the fact that gravitational waves will intersect, or 94.7% chance that the gravity will turn off? I don't understand. Gravitational waves are extremely weak, so weak that we had to build detectors that perform the most accurate measurement in the history of humanity to detect them. On top of that, the gravitational wave signals represent only the final seconds of the collision, not something that we can see in advance. Also, between what 2 black holes? Like one from the Milky Way and then one from another galaxy? Like, I don't understand. Given that gravitational waves move at the speed of light, if NASA can now predict them, they must have some pretty physics-defying technology. On top of all that, NASA does not study gravitational waves. It's the LIGO Virgo Cagra collaboration that observes them. So how could the Earth lose its gravity? Well, basically, you need the planet to lose... Yes, this is what I was saying. The planet would have to lose its mass somehow. And fast. Somehow get rid of the core, mantle, crust. Oops, you don't have a planet anymore. If you have an object with mass, that object will produce a gravitational field. Even we produce gravitational fields. They're just very, very small because we don't have as much mass and density as, like, a huge rock, basically. There's no way to stop it without getting rid of the mass. There are enough real threats in the world, from the climate crisis to global health concerns, very real and very happening right now, combined with governments ignoring the need for vital and immediate action, and in some cases exacerbating them. True stuff. You don't have to make stuff up like the planet's gravity is turning itself off to scare people for clicks. Okay, so I guess it was just some random bullshit, just like we get every couple of months of like someone being like, hey, the world is gonna end. It's crazy, man. And here's how I know why. Buy in to find out. Give me money and I will tell you. But yeah, if you honestly, if you hear any rando saying that the world is ending, don't worry, it's not. There's zero chance of it. It's the only hard thing to tell is whether they're intentionally you know, trying to be fear-mongery, or if they're just stupid. That's the only scary thing. Maybe they didn't take their meds that day, I don't know. But you know, it's always a little silly to giggle at something like this, even though, like they said, some very real global health concerns going on. But yeah, that's basically all I had today. Thank you to everybody that came by. I appreciate you. This is pretty good. I'll probably try to I'll try to remember to do it more often. I think just for a bit it felt like there wasn't too much going on, but I just gotta check, you know, regularly. But alright, that'll be it for me today. Thank you everybody came by. I appreciate ya. Hope everyone has a good rest of their day or night. And I will see you next time. Goodbye.